Of course, there are many challenges, and one key challenge what we address is the materials, and especially this critical raw material. And as you notice that there is the number of turbines are increasing, and there's a more and more demand for the material, and at the same time these materials need to be circular. And as you know that wind turbine size are increasing, like today operational wind turbines are like 50 megawatt, and there are also 22 megawatt which Chinese are building, and the blade size is increasing from 150 meter to close to 200 meter. And then you need large volume of the composite materials, and you also need a lot of rare earth magnet, especially when you are working on the direct drive wind turbine. And one of the key challenge, which is the dependence on the EU, dependence on the third countries. Like in this case, imagine if you want to buy permanent magnet, it mostly come from the China, and they have put the export control, and most of the European producer, they are facing this dilemma actually. So that's why I feel that the material itself is one of the key challenge. But of course, when you talk on the entire wind farms and thing, then it goes more further down on the grid integration. And they are basically, because as you know in the many stories that there is a lot of wind energy or in general renewable energy production, but the main problem is to how to integrate with the grid. That's how you see always the curtailment, and a lot of issues are there. But that's another side of the aspect. When you talk about on this specific, like where our projects are focusing, like we are focusing on the single turbine, then I believe that the material is the key challenge for us. So one of the things is that we need a very good synergy between the academia, industry, so in such a way that they can sit together and they basically come with innovative designs and innovative way to basically implement this solution. Because when you say the scaling, it it boils down to the manufacturing, and the automation is one of the key component. And what our Made4WIND project is also addressing this aspect, because we are trying to not directly introducing the automation itself, but we are introducing a pathway. For example, one of the thing which we are addressing is a preform, where it's like a Lego concept, where you basically build a small Lego and you ship it to the close to the site, where you basically just connect and you make a blade. So this way basically you're reducing the manufacturing time, and at the same time you're also reducing the defect, number of defect, because everything is automated now. So that's why like the manufacturing is the key. Same thing with, there has to be innovation on the generator side also, because they have to be made more compact, and for that we have to do a lot of innovation, because still we are relying on the conventional technology. So that's why our project like Made4WIND project is addressing, coming with this compact drivetrain, where you can use the best of gearboxes and the best of the direct drive. So you can optimize like the amount of material you use, as well as you can also increase the maintainability in such a way that, because you have good control on the component design. And then again, there is also a key aspect on the automation. If you can introduce automation to the in the gearbox and in the all the manufacturing assembly, you can scale down the, you can reduce the time, and hence you can produce a lot of component. So I would say the mega factories, if you are the mega factories of the wind, like the way the car is produced today, there's a lot of automation. You can produce and you can design car in a very faster rate, and then the new cars are coming in a much faster space. If we can do similar thing with wind turbines manufacturing, I think so we can reduce the cost significantly, and we can scale up this whole industry in a much better way.